Right, materials. Explain how copper conducts electricity. Well, copper is a metal. So why not just do a quick little diagram of metallic structure, which is nice neat rows of atoms, all the same size. Each atom is an ion, it has a positive charge, like so. Okay. And the electrons exist in this mysterious space between the atoms, like so. Okay? But to get the marks in this question, you do actually have to use words and explain. So it's 2 marks. Right. So say that the electrons are delocalized. Right? Always a good phrase to use. What else can you say? Therefore, because they're delocalized, they're free to move through the metal. And that answers the question. That explains why copper conducts electricity. 2 marks. Okay. Next question. Explain why diamond is hard. Right. Well, quick diagram, doesn't do any harm. But these diagrams are good for your brain anyway. Good revision. So diamond has this kind of structure. Diamond is made of pure carbon, believe it or not. So diamond is made of the same stuff that pencil lead is. Exactly the same material, pure carbon. It's just that the atoms are arranged differently. And that's why diamond looks so different to pencil lead. Okay. So diamond has this kind of a structure. Each of these is a carbon atom, and each one is bonded to 4 other carbon atoms, and it just continues like that. Okay, so something like this, but forever. Okay, so get this phrase down. Carbon is a giant covalent structure. Covalent, yeah, use the word structure. Okay? These bonds between the carbon atoms, that single line, it's a covalent bond. Okay? So you've got covalent bonds throughout the entire structure, holding it all together. And covalent bonds are strong. And that's why diamond is hard. Yeah. It's a 2-mark question, so that'll get you the marks. But you could mention that in the giant covalent structure, each carbon forms 4 bonds in diamond. Not in graphite, by the way. In diamond, carbon forms 4 bonds to the other carbons. Whilst we're at it, graphite has a layered structure. So graphite, pencil lead, like I was talking about, the carbons are arranged in this kind of a structure, in layers, like so. Okay, so this is graphite. Each one of these is a carbon, and you can see that each carbon is only bonded to 3 other carbons, and this is unusual for carbon, but it does happen in pencil lead and graphite. So you've got this layer here, and then you have another layer underneath it, same structure. Okay? And the electrons are delocalized in graphite, and the electrons live in this space in between the layers of carbon, which means that they're free to move in this direction. So graphite can actually, believe it or not, conduct electricity, even though it's pure carbon, because the electrons can move in between the layers. Okay, this is extra information for your future exams. It's not answering this particular question, but it's likely that that will come up in your exam. So that's graphite. And the carbons form 3 bonds. Diamond cannot conduct electricity because there are no delocalized electrons. It's only graphite that can. Okay. Explain why thermosetting polymers are better than thermosoftening polymers for saucepan handles. 2 marks. Well, thermosetting polymers, they have a much higher melting point. Okay? Or you could say that they don't melt when heated. These are clearly desirable properties for a saucepan of a handle, which gets very hot. What else could we say? Yeah, thermosoftening polymers. So thermosoftening polymers, they go soft when heated. Clearly undesirable for a pan handle. What else could we say? Right, yes. Let's give the actual reason. So, okay, that's thermosoftening, this is thermosetting. Thermosetting polymers have, this qualifies as something, a point. Thermosetting polymers have crosslinks. Get that down on the answer sheet. Crosslinks between the hydrocarbon chains. And that's why they have a much higher melting point. These crosslinks maintain the structure even when heated. So thermosoftening polymers have this sort of a structure with no crosslinks. Thermosetting polymers, okay, there are these crosslinks between the chains, okay, like so. There we go. Materials. Super stuff.